So I want to touch base really quick, just review some misconceptions about evolution by natural selection, and this will be relevant to the activity that we're doing today. Just to remind you, this idea that evolution does not perfect organisms. And so the giraffe is sort of a silly example here of this idea that, there's a lot of advantages of a giraffe having a long neck, but there's a lot of cost to a giraffe having this big, long neck. And you can see one of the costs here. When a giraffe has to take a drink, it's got to do the splits and it's got to put out a lot of effort, right? And so this is the idea of an evolutionary trade-off. So an evolutionary trade-off is basically this idea that every trait has a fitness-related cost and a fitness-related benefit, okay? So nothing is free in the world of evolution. Any sort of benefit that you get is going to have a cost too when you're talking about traits. And the important thing is that for a trait to be selected for and sort of spread throughout a population, for a trait to be considered an adaptation, the benefits have to outweigh the costs. And so a great example of this that's often used is sickle cells or sickle cell anemia. So sickle cell, if you've never heard of it before, this is sort of what normal blood cells look like. But there's these alleles that can cause this thing called cell sickling, which results in sickle cells. So sickle cells are basically shaped like this little sickle shape. And because the red blood cells are sickle shaped, they end up clotting. So they end up sort of getting jammed up in your blood vessels and causing blood clots. And this can have a lot of obviously negative effects. Oftentimes this can result in really painful blood clots and even death, okay? And so there's a really strong selective pressure against sickle cells. But as it turns out, if you have some sickle cell alleles, and if you're heterozygous for sickle cell alleles, they can actually confer resistance to malaria infections. And so there's actually some places, if malaria is super high in prevalence, where it's actually beneficial to have these sickle cells because it can protect you from malaria and allow children to survive to reproductive ages despite having malarial infections. And so that's going back to this idea that the fitness of a trait depends on the environment. And we use this really silly example of this guy, Gortat, that's, like 7'6", which is a great trait to have if you're playing basketball. But if you're driving a car or doing almost anything else in life, being that big is pretty disadvantageous. And so it's the same idea here with sickle cell anemia. There's certain contexts where having those sickle cells can actually be advantageous. In other places, it's super, super costly. And in fact, if you look at the rates of sickle cell alleles in Africa and the distribution of falciparum malaria, so this is one of the pathogens that causes malaria. So this orange represents the distribution of malaria in Africa, and these colors represent the sickle cell or the prevalence of sickle cell alleles in Africa. And what you can see is there's really high prevalence of these sickle cell alleles in areas where there's higher prevalences of malaria. And so you actually have selection for those alleles, or those alleles are favored in these areas where there's lots of malaria, because that confers resistance to malaria, and children with those sickle cell alleles can have higher rates of survival. And so this is once again making this point that the fitness of a trait depends on the environment that you're in. So if you're in an environment with a lot of malaria, it's actually advantageous to have this normally disadvantageous trait of sickling.